start on notes. Moving on to chapter 8, which is graphing quadratic functions. We're going to start off by talking about our parent function for quadratics. This is f of x equals x squared. Okay, so our quadratic parent function is f of x equals x squared. This is the simplest function in the quadratic family. The graph of the function is called a parabola. So what I want to do first is I want to fill out this table. I just have a bunch of points. I have -2, -1, 0, 1, and 2. It's just so I can see a little bit on the left side and a little bit on the right side. What I want to do is I want to plug these numbers into the function. So if I'm going to do f of x equals x squared, what I want to do here is I'm going to plug in my -2. When I do that, I want to make sure it's in parentheses. So I have -2 squared, which gives me 4. And I want to do the same thing for -1. So what's -1 squared? Positive 1. 0 squared? 1 squared? 2 squared? 4. Okay, so then in my next column, I want to go ahead and write my coordinate points. This is my x, this is my y. So it's going to be -2, 4. What's my next point going to be? My next one? Next one? Next one? Okay, so if I take a look at these y values, notice how 0 is my lowest y value. This is going to be my vertex. So I want to say the vertex is the highest or lowest value. Okay, then I want to go ahead and graph my points. So I'm going to start at -2, 4. That means I go left 2, up 4, and put a dot. Then I have -1, 1. So I go left 1, up 1. 0, 0. I stay at the origin. 1, 1. I go right 1, up 1. And then 2, 4. I go right 2, up 4. And I want to connect my points. Okay, so I want to write that the parabola opens up. Then if I take a look at this, if I cut this graph in half and folded it over, it would reflect on itself. This is called an axis of symmetry, and on this graph it's x equals 0. And so looking at this graph, I can see my vertex right here. Again, it's 0, 0. So our axis of symmetry intersects the vertex and divides the parabola in half. So my axis of symmetry will always be the x value of my vertex. Okay, so this next one wants me to see how the leading coefficient a affects the graph of f of x equals ax squared. So now I'm putting a number out front, and I want to see how it's changing it from that graph we just graphed. So I want to compare this to the graph of the parent function. The first thing I'm going to do is I'm going to graph the parent function. That's the same graph we just did on our last problem. So that's the one that had the points at negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Those points will always be the same for my parent function. And then remember, our parent function was called f of x. So I'm going to label this on the graph, f of x. Okay, then I want to find the values that belong in my table. So I want to plug these in. I'm going to use the same values to plug in for my x's. So I'm going to do 2, because the 2 is on the outside of the function here. And then in parentheses, I'm going to do negative 2 squared. So that first y value is 8. And I'm going to do the same thing for the next one. So I still have that 2 on the outside. Now I'm squaring negative 1. This one gives me 2. What do I get when I plug in 0? And 1? Now I want to go ahead and write my coordinate points out. So my first one's going to be negative 2, 8. What's my next one? My next one? My next one? 1, 2. And then my last one? 2, 8. So I want to go ahead and graph these. This graph, the grid only goes to 7, so my 8's going to be a little bit off. Then negative 1, 2 will fit. 0, 0 is in the same spot. 1, 2, and then 2, 8. So again, I want to go ahead and connect my points. And I'm going to name this one g of x. Okay, so what do you notice about the blue graph compared to the red one? Yeah? Kinda. So, yeah. Okay, so the second one's taller. The word I'm going to use is narrower. And then this transformation is called a vertical stretch. So what's happening here is if we imagine a rubber band, and this is just the way the rubber band normally is, if I stretch it vertically, so up and down, it gets skinnier. So that's the same thing that's happening with our graph right there. We're stretching it vertically, so it's getting skinnier. So what I would do for this answer is I would write that this graph has a vertical stretch of 2. Why did I say the number 2? Yeah, that's my coefficient on my x squared. So on the back side, this one again wants me to compare it to the parent function, so I'm going to start off by graphing that parent function. So that's negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Oh, parent function was called f of x. So then when I go to plug my points into my calculator here, I'm going to do 1 divided by 2, and then parentheses negative 2 squared. So that gives me 2. What do I get when I plug in negative 1? 0.5. And 0? 0. 1. And 2. So then my coordinate points are my next one. And my next one. Okay, so I want to go ahead and plot these points. Okay, so what do we notice about the red graph compared to the blue graph?
It's smaller.
Okay, it's smaller. The word I'm actually going to use here is wider. So this is called a vertical shrink, or you might also hear it called a compression. So if I think back to this rubber band, that's what it normally looks like. And if I shrink it together or if I compress it together, it gets wider. So that's what's happening with our graph. Then I just need to answer this with words. So this is a vertical shrink of 1/2. So again, C is comparing to my parent function. That is the -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4 graph. So when I go to type this one in the calculator, I'm going to have the negative out front from the equation. Then I'm going to have parentheses, -2 for the number I'm plugging in, and then I square that. So this time it's giving me -4. So what's my coordinate point here? Oh no, not coordinate point. Let's go down this list. What do I get when I plug in -1? -1. What do I get when I plug in 0? 1. And 2? -4. What? Okay, so then I want to write my coordinate points. What's my first coordinate point? My second one? My next one? My next one? And my last one? And I just want to go ahead and graph those. So I have -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. So I'm going to go ahead and connect those. So how is the red one different than the blue one now? Yeah? Yep. So that's my first blank, is it's opposite the parent function. And what do you think the official name for this is called? A reflection. So then all I have to say for this one is reflection. Huh? This last one we're not graphing. We're talking about increasing and decreasing intervals. So it's just that's something just a little different. So a graph is said to be increasing when the y values on the graph are increasing, and it's decreasing when my y values are decreasing. So we'll take a look at a table of values to see what I mean by that. Do you want me to say what intervals f of x equals 4x squared is increasing, and then what over what intervals it's decreasing? Forgot to write the 4 right here. So first thing I need to do is I need to put my numbers in my table. So what do I get when I plug in -2? -1. 0. 4 and then 16. So what is my coordinate point here? And my next one? my next one, my next one, and my last one. Okay, so what I want to do here is I want to compare my y values on this. So to go from 16 to 4, what do I have to do? I'm looking for adding or subtracting patterns. Minus 12. To go from 4 to 0, minus 4. To go from 0 to 4, add 4. To go from 4 to 16. Okay, so notice how these two, that should have been a curly bracket, that's not what I meant to draw. These two, notice how they're both negative. This means it's decreasing. And then the number that it stops being negative on is 0. So for my x value. So I'm going to say decreasing for x less than 0. And it's increasing for the last half for x what? Where does it start going up? At what number? After 0. So x is greater than 0 for my increasing.